You know, when you think of a robot, you probably picture something made of metal and wires, right? Something rigid and strong. But what if the future of robotics is actually soft? So today, let's dive into the incredible story of how engineers are building an artificial jellyfish.
Okay, so to really get why this is such a big deal, we need to start with a massive engineering problem. How in the world do you build a machine that can survive in pretty much the most hostile environment on our planet, the bottom of the Mariana Trench?
I mean, down there, the pressure is just immense. We're talking about 8 tons of force pushing down on every single square inch. Think about that. It's the kind of pressure that would instantly pulverize most conventional submarines. So our first instinct, our traditional engineering approach, is to fight back, right? To build something strong enough to withstand it. But that leads us straight to the problem with metal.
Yeah, the conventional solution is just brute force. We build these robots like deep-sea tanks with incredibly thick, heavy, and you guessed it, wildly expensive metal hulls. They're designed to physically block the water out, which means it's just this constant, energy-intensive battle against the ocean itself.
But here's a thought. What if fighting the ocean is the wrong approach entirely? It turns out, nature came up with a far more elegant solution millions of years ago.
And when you look at them side by side, it's a total clash of ideas. A rigid robot fights the pressure with its heavy shell, but a jellyfish, it does something completely different. It matches the pressure. It has no bones, no shell, so there's nothing to crush. It doesn't just survive down there, it thrives.
And this comparison sparked a really revolutionary question for engineers. Instead of building these armored boxes to try and conquer the ocean, what if we built robots that mimic the creatures that have already mastered it? This right here is the foundational idea of soft robotics.
Okay, so the idea is brilliant, for sure, but how on earth do you actually build a squishy robot that can move effectively without any of the usual stuff? No gears, no joints, no electric motors.
Well, the answer is a technology called Fluidics, and the best way to think of it is like a really sophisticated water balloon. Instead of motors, these soft robots use artificial muscles made from flexible stuff like silicone, and they're powered simply by pumping fluid, either liquid or gas, through tiny channels inside them. And how it works is it's beautifully simple, really. It's a 3-step process. First, you fill these tiny channels inside the silicone body with fluid. Second, that pressurized fluid makes the flexible material expand and change its shape. And finally, by precisely controlling where and when that expansion happens, you get controlled, lifelike movement. A pulsing bell, a curling tentacle, all without a single gear.
And look, this isn't just some cool idea on a whiteboard. A team at Florida Atlantic University has already built a jellyfish robot that swims by pumping water to create jet propulsion, perfectly mimicking the way the real animal moves. It's happening now.
All right, so we know it's possible, but why go to all this trouble? What makes it so much better than a traditional metal robot? Well, this soft, squishy design gives it some incredible, almost unbelievable superpowers.
First up, pressure immunity. Because the robot is made of materials like silicone and is filled with water, things that don't really compress, there are no hollow air spaces that can get crushed. What that means is the same robot can operate perfectly at 10 meters below the surface or 10,000 meters down at the bottom of a trench. No heavy, expensive hull needed.
Superpower number 2, it's basically a ninja. It's got acoustic stealth. Propellers and motors are loud, and all that noise scares away the deep-sea wildlife we want to study. These soft robots, they just silently pulse through the water. This lets them get close to incredibly shy creatures, like the elusive giant squid, without causing a panic. It gives scientists a truly undisturbed view of life in the deep.
Okay, those are amazing, right? But its most game-changing ability, the one that could truly revolutionize marine biology, is something scientists are calling the gentle grip.
To get why this is so important, just picture this. You're trying to use a big, clumsy metal claw to grab a super fragile piece of deep-sea coral. An analogy I heard captures it perfectly. It's like trying to pick up a grape with a pair of pliers. You're almost certainly going to crush what you're trying to study.
But a soft robotic gripper? It's completely different. It can just envelop a delicate sample, gently wrapping around it like an octopus tentacle. This lets scientists collect and study the most fragile life forms from the deepest parts of the ocean with absolutely zero collateral damage. It's non-destructive science in a place we could barely even touch before.
So you can see this technology is incredible for exploring the ocean. But it also points to a much bigger, more fundamental shift in how we think about engineering. a shift that's impacting everything from delicate surgical tools to gentle grippers in factories. The whole philosophy behind this field actually has a name: biomimicry. It's the simple but really profound idea of looking to the natural world, which has had millions of years for R&D, for inspiration to solve our own complex problems.
And this just illustrates the change in mindset so perfectly.
For decades, we tried to conquer extreme environments with brute force. We built bigger armor, stronger engines. Soft robotics shows us it's far more effective to stop fighting the environment and start learning from it.
The crucial takeaway here is that we're moving from a purely mechanical age to a biological one. And that leaves us with a truly incredible thought. Maybe the future of exploration isn't a metal submarine, maybe it's a silicone jelly.